the normal approximation to the binomial distribution. So we're going to have a look at how we can approximate the binomial distribution using the normal distribution and when we're allowed to do this. So you'll remember a while back we compared different distributions changing the probability. We actually did it for n equals 20, but this is for n equals 10. When we have a small probability or a large probability, the distributions are skewed. If we increase the number of trials, say 20, 50, 100, the distributions become more symmetric. When n is large and p is close to 0.5, that's the probability, so lots of trials, probability close to 0.5, then the binomial distribution is similar to the normal distribution. Also, the mean and the standard deviation of the distributions agree with each other, they're the same, or very close. So, when n is really large, when we do lots of trials, scientific calculators, in particular basic calculators, cannot calculate the arrangements. A scientific Casio calculator or TI calculator can't do this. So what we can do when n is large and p is close to 0.5, we can use the normal distribution to approximate the binomial distribution. Now, if you recall, with the binomial distribution, if x is a binomial distribution with n trials, probability of success p, then the expected value or the mean was n times p, and the variance was n times p minus 1. That means that if we have a binomial distribution, we can approximate it with a normal distribution that has mean np and variance np p minus 1. And the general rule is that the normal distribution can be used as an approximation when both np and np times 1 minus p are greater than 5. And just a quick reminder that we can standardize our data values by taking our data value, subtracting the mean and dividing by the standard deviation. So let's have a look at an example. We've got a sample of 1,000 people from a certain city. They were asked to indicate whether or not they were in favour of the construction of a new freeway. It's known that 30% of people in this city are in favour of a new freeway. We need to find the probability, approximate probability, that between 270 and 330 people in the sample were in favour of the new freeway. So we need to define our random variable, so we're going to say let x be the number of people in the sample who are in favour of the freeway. So we can say that x is a binomial distribution with 1,000 trials with a probability of success of 0.3. The expected value of x is n times p, so that's 300. The variance of x is n times p minus 1, so that's 1,000, 0.3, 0.7, that's 210. So I can approximate x with z, which is not standardized yet, but a normal distribution with a mean of 300 and a variance of 210. To find the probability that x is between 270 and 330 is approximated by, so we've got z in between 270, subtract 300, the mean, divided by the square root of 210. Remember, we divide by the standard deviation, so we've got to take the square root of the variance. And then our upper value is 330 minus 300, divided by the square root of 210. Use your calculator to work those out. And then to find what the approximate probability is. So, for these questions, you're going to use the normal approximation to the binomial distribution, you will always be told when to use it. So there's questions 1 to 6. Make sure you mark your work and ask if you have any questions.